Jasmine, and I'm going to be teaching you about linear approximation. The first step of linear approximation is to look at the value and use that to find the function. For example, let's approximate the square root of 230. Given this value, we know that the function is f of x equaling the square root of x. Now, in order to approximate the square root of 230 using linear approximation, we need to pick a value also in the function that is easy to solve. In this case, we'll pick the closest perfect square. But when dealing with decimals and other functions, I suggest picking the nearest whole number. 230 is pretty close to 225, which is a perfect square, and the square root of 225 is 15. So let's put f of 25 equals 15. The next step is to find the derivative at our chosen x, or 225. I think a common mistake here is that someone will see f of 225 equals 15 and automatically think the derivative is 0 due to 15 being a constant. But in actuality, we want to find the derivative of the original equation, which means f prime of x is equal to 1/2 x to the negative 1/2 power, or 1 over 2 root x. When we plug 225 into this equation, we get f prime of 225 equals 1 over 2 root 225, or 1 over 30. The next step is to make the tangent line and then plug our known values into the said tangent line. The tangent line can be written as y minus y1 equals m times x minus x1. Plugging in our known values, we get y minus 15 is equal to 1 over 30 times x minus 225. Rewriting this in slope-intercept form, we get y equals 130x plus 15 over 2. The last step is to plug in the value we are approximating for x, which results in y equaling 1 over 30 times 230 plus 15 over 2, which can be simplified to equal 91 over 6, or 15.167. Let's try another example. Let's approximate 7.5 to the 2/3 power. Given this value, we know that f of x is equal to x to the 2/3. Since this is a decimal, we should round to the nearest whole number. The nearest whole number is 8, which, lucky for us, is an equal equation for this. 8 to the 2/3, or f of 8, is equal to 4, because 8 squared is 64, and the cube root of 64 is equal to 4. F prime of 8 is equal to 2/3 times 8 to the negative 1/3 power, or 2 over 3 to the cube root of x. Since x is 8, we're just going to plug in an 8 there. So 2 over 3 and then 8 cubed is 2, so that is equal to 2 over 6, which is 1/3. This means that the tangent line is written as y minus 4 is equal to 1/3 times x minus 8. This can be simplified to equal y equals 1/3 x minus 8/3 plus 4. We can't add these yet because they are uncommon denominators, but once we make them common, we get y is equal to 1/3 x plus 4/3. When we plug in 7.5, or 15/2, into x, we get y to equal 23 over 6. Another part of linear approximation is finding linearization, or ln x, at a given a. For example, let's look at the function sine of 2x when a is equal to pi over 2. Similarly to the first problem, we need to find f of x and f prime of x at a value, but instead of picking a number close to pi over 2, we are going to use pi over 2. Once again, we need to plug in sine of 2 times pi over 2, which is the same thing as f of pi over 2. You may know this, but sine of 2 times pi over 2 is the same thing as finding sine of pi, which is equal to 0. Using the chain rule, we know that the derivative of sine of 2x is cosine 2x times 2 So when we find f prime of pi over 2, we get cosine of pi times 2, which is the same thing as negative 2. The tangent line, instead of being written as y minus y1 is equal to m times x minus x1, we are going to replace this y and put it as L of x since we are just finding the linearization. When we plug in our known values, we get L of x to equal negative 2 times x minus pi over 2 plus 0, which is the same thing as negative 2x plus pi. There's our linearization. The last part of linear approximation is telling if your approximation is an overestimate or underestimate, which can be found by graphing the original equation as well as the tangent line. An overestimate is when the tangent line is above the original equation at the approximate x, while an underestimate is when the tangent line is below the original equation at the approximate x. Let's try an example. We can approximate x equals 3.1 with the function x squared minus 2x. Similarly to the second problem, we can round this to the nearest whole number, which is 3, and then find f of 3, which is 9 minus 6, or 3, and then f prime of 3, which is 2 times 3 minus 2, which is equal to 4. And this means our tangent line is y minus 4, which is equaling to, y minus 3, which is equaling to 4 times x minus 3. When we simplify this out, we get y minus 3 equaling 4x minus 12, which is the same thing as y equaling 4x minus 9. Let's graph this. So y equals 4x minus 9, 7, 8, 9. We know at 0 is going to be 9, obviously. And it's just going to go down from there. So 4x, that's negative 5. And I'm just going to put a couple values here just so we can get like a kind of accurate sketch of the tangent line. And so 12, 1, 2, 3. Next, we're going to graph our equation. So x squared minus 2x is going to be here, and then 1 minus negative 1, 2 squared minus that. We know that this is the vertex here. So 3 squared is 9 minus 6, which is 3. And then negative 1 is also going to be 3. So when we look at the equation 3.1, we see that the value is right here, which means that the tangent line is slightly above the curve. And we can also check this by plugging in 3.1 here, which would be 4 times 3.1 minus 9, which is 3.1 times 4, 12.4 minus 9. So it's going to be about 3.4 at the tangent line. And when we put in the curve here, and if you were to plug it into your calculator, you would see that it is a slight underestimate or overestimate. So thank you again for watching, and I really hope you enjoy my video. Thank you.